Okay, this is hypothesis testing with using the p-value approach, and sigma is always known with the p-value approach. This is question 4A on your practice final. And this is the study of starting salaries at a university. In 2005, the average was found to be 35,000. And we want to know whether that value has changed since 2005. So H naught, the null hypothesis, is going to be mu naught equals 35. H1, the alternative, is mu naught is not equal to 35. Because the problem in question 4A says we want to know if that mu has changed, if the average salary has changed. So has changed means not equal to. Now, they tell you sigma is 3.2 thousand, and they took a sample of 10 starting salaries, and they found the mean of the sample is $37.5 thousand. Now, alpha, the level of significance, is given as 1%, 0.01. So here's how we do p-value. We calculate the test statistic z, which is x bar minus mu naught over sigma over root n. And that's where the tails begin, at plus or minus z. And this is 2.47. So the test statistic is 2.47. X bar is the mean of the sample, minus mu naught, that's in the numerator, and in the denominator, sigma, which is 3.2, over the square root of 10. And if you do the math, you'll find that's 2.47. So that's where the tails begin. It's a two-tailed test. So the left tail begins at negative 2.47, and the right tail begins at positive 2.47. So this is where the right tail begins, and this is where the left tail begins. Now the p-value is the area of the tails. There's two tails in this case, so we add up the areas of the tails. So if you go to table 2, you'll find the area to the left of negative 2.47 is 0.0068. And the area of the right tail is always the same as the area of the left tail. So this right tail begins at positive 2.47. So P is going to be 0.0068 plus 0.0068, which, if you add them up, P is 0.0136. And now we ask the question, is P less than alpha? And since alpha is 0.01, the answer is no. Therefore, the conclusion is do not reject H naught. Since you ask the question, is P less than alpha? The answer is no. So that is the p-value method on question 4.